Well, hello there. It is KP the Math G. I took a day off yesterday. I was so tired from, well, my wife and I stayed up and watched television till about, well, 1 o'clock. And I tell you what, I stayed in bed until 1 p.m. So I usually don't do that. And so we got up, and this is the first time to get out from the snow being on the ground, and we just took a little time to have a little time for ourselves. So this is one time that I'm able to do this, and I do want to share with you that this graph is from a question back in 2004, question number 5. This is their definition of the integral. It's called g at x. I want to say that this is the graph of f here. Yeah, I think that's right. And we want to take a look at this graph. It's got so many things, so many questions. Matter of fact, this is the questions that I'm asking you are not exactly the same questions that they have asked you. So in a sense, this is not, I mean, even though this is their graph, my questions are a little different than theirs. Okay, let's get started with these questions. I have areas here of 1 and -1, and you might wonder why, after I've done so many videos, that the bottom number's positive and the top number's negative. Why those areas, why should this be negative and this one be positive? Well, I'll show you why that answer is so obvious after a while. This area from -3 to 0 is 9/2. Well, actually, this area from -5 to 4 is 1. This area from -4 to 3 is -1. I'll explain that. This area from -3 to 0 is 9/2. These little areas under the curve here, I figured them to be 2 minus pi over 2. And I'll show you, this is actually a hemisphere, even though it looks like a parabola. It's not. It's a hemisphere, and I can show you how to get that, how to derive that. So I did that. And then this area of this triangle is 1/2, and this area of this triangle is -1/2. It makes sense on this side, but now this doesn't make sense to you, does it? Yeah, well, it's given by this function here, and so that's what we're dealing with. We have a triangle and another triangle of the same area. This triangle and this triangle are of the same area, although one is 1/2 and one's -1/2. They still have the same absolute value area. Okay. Now, and then this area here is a little more difficult to find, but it's 2 minus pi over 2. One can expect that pi to be in there from a circle. Okay, so alright, these are all areas, and I don't want to mess it up too much, but this is the area here, and this area here, and all this area here, and then this area down here, and this area down below here, and this area up here, and then this area down here. Okay, so from -5 to 4, we have the summation of all these areas. Just as a quick, just without doing any work, and just take it at face value that I've got all of these correct, I'm going to show you the difference between displacement area, alright, and then what we have total area. So I'm going to base my first video on that. Alright, if we have time, I will show you how to find each one of these areas. Alright, so total area. Be suffice that these are correct. I will tell you that. So all you're doing if you're dealing with displacement area from -5 to 4 is you're going to add up all of these areas under the curve. Okay? Okay, so here we have 1 plus -1 plus 9/2 plus 2 minus pi over 2 plus 1/2 minus 1/2. Okay, notice these are going to cancel. This is 0. 1 minus 1 is 0. 1/2 minus 1/2 is 0. So all we have is this right here. And I'm just going to get the same denominators on these two. So 9/2 plus, okay, 2 times 2 is 4. I told you how to do that. So 4 over 2 minus pi over 2. And that's equal to 4 plus 9 is 13. So 13 minus pi rather. 13 over 2 minus pi over 2. So again, all I did was add up all of these areas. Alright, if I'm looking for the displacement area over this time from -5 to 4, taking that I've already found these answers ahead of time. I actually have 3 more lessons on this very same problem. And I do want to go over that with you, okay? Alright, and I don't know if it's 3 or 3 more or 2 more, but I'm thinking 3 more. And I want you to get to see the idea behind this, because we're going to get back into max and mins and all of that again. Alright, total area. What is it? Well, you're taking the sum of all these again, but everything has an absolute value around it. So the first number is 1. Well, the absolute value of 1 is 1. So a positive number I will not take the absolute value of, because the absolute value of a positive number is that. But I guess for simplicity purposes I will. So the absolute value of 1, the absolute value of -1, the absolute value of 9/2, okay, the absolute value of 2 minus pi over 2, the absolute value of 1/2, okay, and then plus the absolute value of -1/2. Alright, everything's positive. Total area is kind of like moving this part up here. Instead of it being down here, it's moving up here. It would be more like this up here. Okay. This portion would be up here, above the x-axis. The absolute value puts it up there, and this part right here would be too. Alright, it would be up here like this. Alright, so everything, this would not be down here. You would not see any of this. So 1/2 here, and instead of well, it'd still be 1, but still up here. And then this one actually would go down below, since it's -1. That would make it 1. But anyway, the absolute value of all of these areas. So 1 plus 1. Now it's not -1. They don't cancel out anymore. And neither does 1/2 and -1/2 cancel out. Alright, so now plus 9/2 plus 2 minus pi over 2. The absolute value of 2 minus pi over 2 is 2 minus pi over 2. It's not plus. You don't put a plus in the middle. This is one number, okay? It's kind of like the absolute value of 6 minus 5, which is still 1. Absolute value is still 6 minus 5, okay? Alright, so plus 1/2. Alright, and then plus another 1/2. Alright, we know what a half plus a half is. That's 1. Alright, so let's see. Let's get all the whole numbers. 1 plus 1 plus 2 is 2 plus 2 is 4 plus 1 is 5. So 5, I'll put it up here. I don't have much room, guys. Guys and girls. 5. So 1, let's check it off. 2, 3, 4, and then this is 5. Well, half plus a half is a whole. Alright, so that's 5 plus 9 halves plus, oh, what's it, minus? Yeah, minus pi over 2. Minus pi over 2. Alright, so again, 2 times 5 is 10. 10 over 2 plus 9 over 2 minus pi over 2 is 19. Right? 10 plus 9 is 19. So this answer here for total area is 19 over 2. 19 over 2 minus pi over 2. Okay. And the difference being is these are now these absolute values. This negative 1 is now 1, and this negative 1/2 is a whole, and then now these do not cancel each other out, and neither do these. So you've added 1 plus, you've added an extra few more to it. It makes sense that this is 19 over 2 minus pi over 2, and this is 13 over 2 minus pi over 2. Okay. And that's basically what I wanted to show you on this first video, is that once you get these individual areas, you can go ahead and figure out the displacement or even the total area. Depends on what they're asking you. If they want the total, maybe total distance, maybe it's not saying total area, they may be asking for total distance, okay, or total amount of something, okay. So when you see total anything, you're going to take these absolute value bars, and everything is going to be taken as the absolute value. So keep that in mind. Okay. Alright, let me see if I can show you at least how each one of these areas are derived. Okay. Alright, let's see here. I have to leave this up here for the next few videos, but maybe I have time to show you. My camera goes only a little over 30 minutes, so I can't delay it too long in this. So anyway, alright, let's see what we can find from this. Alright, so in other words, this length is 1 and this height is 2. I know that because that's negative 2. And then so 1 times 2 divided by 2, of course that's the area of a triangle. Base times height divided by 2. Okay, so 2 over 2, which is 1, and it's going to be 1. Alright, so let me explain why it's 1 down here and not negative 1 down here. According to this, we're saying that g at x is, okay, so g at x is from negative 3 to x. Alright, I'm actually going from negative 5 to 3. Okay, and then that's what I do. I put the negative 5 into x if I'm going from, and I'm actually going to, that's, well, x, let's just go ahead and leave the x there. Alright, so x, okay, alpha t dt. Alright, and okay, so if we were to plug these in, okay, we would get, okay, let's see, if I were to plug the negative 5, if I'm going from negative, well, and actually this from negative 4 to 3 is the same area, except this is negative 1 and this is 1. Okay? I'm going to show you why that's really true. I'm trying to think of what I could do here. If I were to plug in, let's say, well, if I were to plug in, let's say negative 5 here, okay, negative 5 right here, okay. Actually, this number is smaller than this number. There's a rule that says if you're going from A to B, F at x dx, and let's put it from B to A. Alright, where actually A is less than B. On the number line, negative 5 is here, and negative 3 is here, and 0 somewhere over here. So negative 5 is less than 3. And there's a rule that says that if that's true on integration, that we switch the limit of integration, but we put a negative sign in front of the sign here. Alright, so that we can put the negative here and put now like it's supposed to be. So, and then F at x dx. And that's what you got to remember when you're doing this right here. So, whoops. Alright, when this is smaller, then this actually flips around to the negative part. Alright, and then you have the, now that looks more proper like that, F at t dt. Okay. Alright, like that. And basically, you're just finding out what this is. Okay, actually this is equal to 0 because these two cancel each other out. If I were to do this, instead of from negative 3, I'd go from negative 5 to, if my x is negative 5 here, if I do it like this, and then I make this from, say, negative 4 instead of negative 3, I still got to flip this around because negative 4 is still larger than negative 5 on the number line. I still got to put that negative out there. Alright, now if I do that, this is actually 1, okay, because the answer down here, if it's below the axis, it's of course negative 1. So this is a negative. We know that this is negative 1 because it's below the x-axis, okay? But it's a negative 1, which makes this one equal to positive 1. From negative 4, okay, here's negative 3 up down here, I think it is. So let's see, yeah, negative 3 is down here, and negative 4 is up here, like that. Alright, so let me put it over here. I don't have much room, guys. Alright, put negative 4 here and negative 3 here, where the negative 3 is supposed to be down here. But if we put the negative sign in front right here, I am going to get negative 3 here and negative 4 here, as it should be. The smaller one, the smaller number has always got to be on the bottom. That's what I'm trying to say to you. Okay, so if the smaller number has to be on the bottom, you got to flip this around. This is not correct, really. We got to flip this around like this. All right, so this is going to be equal to. We know that it's 1 here because it's above the x-axis. So the answer is 1, but it's a negative since this is had to be flipped around like this from here to here, okay? Instead of from A to B, we have to go from from B to A, we got to go from A to B, okay? And so that's where the negative sign comes from. So -1 times 1, this actually is -1. So that's why the areas flip-flop, simply because these two numbers are less than -3. The rest of them will be alright. So like for example, if we go from -3 to 0 like this, alpha x, let's move it over. I'm telling you, I don't want to flip this board over each time. So okay, so if I go from -3 to say 0, alpha t dt, alright, I'm simply going to plug in, I'm just looking at the area from 0 to -3, no further back than that. Okay, I'm just looking at this area here. So this line is dotted, and right here is 0 here. This is a trapezoid. Okay, so if you remember your area of trapezoid, it's going to be base 1, well actually in this case, height 1 plus height 2, alright, times times the base divided by 2. Height 1 is, well, how high is that? From here, there's my y value, that's 2. Alright, height is always the y value. Well, the y value is always the height, so 2. This height here is 1, so 2, I don't know why I'm putting a comma here, plus 1. The base is from -3 to 0, that's 3. And then that's divided by 2. So this is 2 plus 1 is 3. So 3 times 3 over 2, and that's equal to 9 over 2, like that. So this area is 9 over 2. Okay. And, alright. Let's find out what this area is. That's an interesting one. So I'm going to show you how to do that. This is actually going to be from -3. Well, actually, let's do it like this. We're going to go from, we're going from 0 to 2. We want to do it from, we want to figure out the format from 0 to 2, not from 2 to 0. From 0 to 2, what would that be? Alright, well, we can change this, okay. We don't necessarily have to figure out from -3 to 2, although it does say -3 right here. We can still change the bottom one from 0 to 2. Alright, and I can do from 2 to 3, and I can do from 3 to 4. Alright, so let's figure this out. Let's make, and when looking at the area underneath these little curves here, not inside here, it's just going to be underneath here. Well, this is a hemisphere, and the area of a hemisphere is equal to, remember, the area of a circle is pi r squared, but we're dividing this by 2 because it's half a circle and not a full circle. Alright, but now that's part of the answer. We got to have that as well. But we also have, if you think about this, this is a rectangle, okay, like this. So if I can take the area of this rectangle, of the whole thing, minus this right here, then I will get this down below here. Okay? Alright, minus this, so the area of the rectangle, the whole thing, minus this portion right here, will give us these two portions right here. I had to learn that one. Okay, so the area of a rectangle, let's just say R, that is equal to base times height, which in this case, well, base times height. Okay. All right. In the first case, well, let's say the area of the rectangle is base, so 2 times 1. So 2 times 1 is 2. The area of the of this semicircle, okay, I don't know why I said this. It's a semicircle. What am I thinking of? Hyperbola. Did I say hyperbola? Oh, anyway, semicircle is that. Okay, so half of a circle. Okay, so let's see, pi, and we know that this radius is 1. Okay, we know that the radius is from here to here. So this is the radius. Here's the center right here, and the radius. If we had the entire circle, it would be over like that. And so we have a radius of 1. So R is 1. So 1 squared divided by, and this is pi. What am I doing? Oh, this. Oh my goodness, I'm on the wrong thing now. Okay, so 1 squared over 2. Somebody's probably saying, KP, go back to bed. Okay, I just went off on a tangent here. This is 2. 2, all right there, okay. Alright, now 1 squared is 1. 1 times pi is pi. So this is pi over 2. Alright, so this area underneath here we said was the rectangle minus this semicircle. Okay, the area of a semicircle, alright, is going to be pi over 2. So this is 2 minus pi over 2 right here. So this area minus this area here. Whew, that's a lot right there, isn't it, guys? Okay. And then the other two are pretty easy. Alright, if I were to go from 2 to 3, like this, 2 to 3, these are the same if you think about it, because this length, alright, so this is going to be from 2 to 3, alpha t dt, but that's just 1, the base, times the height is also 1, and then divided by 2. So that's 1/2. And then, of course, this is the same thing, but it's negative 1/2. And that's negative because it is below the x-axis. Okay? Going from 3 to 4, that is below the x-axis. Anything to the right of this low number here is still going to be okay, whatever if it's above the x-axis, it's going to be positive. If it's below the x-axis, it's going to be negative. This one is different because it's to the left of these are less than -3, so these signs are opposite. Okay, that's what we're talking about here. These signs are opposite. Okay, and just kind of keep that in mind. Alright, now that is what we have here. And again, to find displacement, you leave every number as is, add them up, these cancel each other out, these cancel each other out, you're left with this plus this, and that's it. Total area, instead of being -1, this is 1. Instead of being 1/2, this is positive 1/2. And so that's where we got the two different answers. Okay, so keep in mind, displacement doesn't matter whether they're positive or negative. Total area, though, total amount, okay, total distance, okay, is going to be the absolute value of all of this. Okay, I add it all up. Okay, I think on the first one we had 13 over 2 minus pi over 2, and that's the displacement. Alright, and this is the total. And I believe we got 19 over 2 plus pi over 2. Okay. Just looking at my answers. It's not plus, it was minus. Minus, 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 minus. Yep, minus. And you could say, put the 2 down, 19 minus pi like this. You can say 13 minus pi like this over 2, since you have the same common denominator. Alright, that's it. I probably squeezed 2 lessons in on one. I just wanted to show you how each one of these are done. This can be tricky, just understand that. But anything to the left of what this is defined to be, these are opposite signs. Anything to the right, just keep the sign that you got. Okay, above the x-axis then, from here on over, is positive, and below the x-axis is going to be negative. To the left of this number, these signs, although that's supposed to be negative, that one's positive, and this one was negative, right? Okay, like that. Okay, and that's really all you got to remember is where is this cutoff? Right here. The cutoff is here. Alright, so to the left of that, these signs change. To the right, the signs stay as they're supposed to be. Above the x-axis is